Whiteboard. Good. So you can write any question we can discuss. Share screen. Oh, here. Can you see my blackboard rather? Okay. This is my pen. So integration or differentiation of trigonometry function?
Both.
Both. Okay. Yeah, differentiation is easier, right? Relatively speaking. To find the derivative, first derivative. Have you studied product rule, chain rule? This is
what is this?
Product rule, chain rule. This is
yes.
this is inverse, right? Inverse sine. Sine X. Then you have to set of formula. Okay. Right. Do you know the formula? I ask. Do you know the formula?
For the chain rule?
No, just for this particular function, it's called inverse function. So sometimes people can write down here. Sometimes people write this way. It's the same thing. The sine inverse, right? It's called arc sine, which means inverse function. Yeah. Do you think you have to solve this by using first principle, or do you want to just use the formula?
I think it's formula.
Yes. Do you know the formula? I have formula. The formula is this. Now did your teacher tell you how to solve that? That is 1 minus x squared, I think. Yeah. It is a formula. Have you seen this formula before? Yeah. Can you find any any page in your textbook with they will give you the frequently used formula?
Yeah, I've seen that formula.
Yeah, you see that formula. So they're not much interested because just use formula. You see, you don't have to derive this formula. Is that required? Just use formula this time?
Yeah.
Okay. So that's it. You just copy it from your formula. As simple as that. Any related question, or why did you find this particular question interesting?
Oh, it was just I kind of just wanted to go over that topic. The whole topic of inverse derivative functions. Inverse trig function.
Well, did you have a textbook? Can we go through your textbook first to see the requirement? Do you have a digital textbook? Can you share your digital textbook? I will stop this slide. Yes, I just have because we need to know exactly what is required, because endless, if you want to go to this type of differentiation, let's stop. You can share. If you have digital book, we just go through the chapter as a whole, right? And to see what are the scope, because it is endless if you just doing the problem one by one. You can share your. Can you see the share screen? You can share screen. Yeah. There are just 3 basic formula for trigonometry function. I mean the inverse trigonometry function: sine, cosine, and tangent. And it depends on the So that is this is a graph, right? That is a graph. Oh, they actually, this is another formula how to get the inverse derivative. Can you see? Can you enlarge this part? I saw this one. Probably that is the formula you need to use. Can you see? Instead of using that directly. Okay, so this one, do you know how to use this formula? Dy dx can be treat as a fraction. And so that as long as that dx dy is not equal to 0, we can put the dy under the dx, just treat it as a function. You see that there are different tricks to solve this problem, because that will give that in that way you will get the formula for the derivative of inverse function based on the derivative of sine in this case. Yeah. So can we look? So this is important. Can we just I think that is a part. Can you just focus on this area? That will give you, this is derived, how do they derive this formula without using the first principle, you see? If we just assume that the inverse function whose derivative is not 0, we can use this formula. We just use this, can we see, can you enlarge this part a little bit? It's too small, this part. Can I annotate?
I don't think you can.
I don't think so. I don't think so. All right. Can we can we just read this, right? Can you see? So that is this result is strange. So but they just use this example to derive the first example, which is can you see, which is a linear function. You see, is a linear function. So what they do is that just use this special example, the linear function, to show how to use this simple relation, namely to treat the derivative as a fraction. Okay, dx dy can be treated as a numerator or denominator. And so that is this is just very brief. Can they just show you that if you from the original function we can obtain the dy dx, and therefore use this phenomenon that dx dy must be equal to 3, which is reciprocal. Can you see?
Yeah.
So in other words, you can this general this is particular trick or method just to show you how to actually derive the inverse sine function from the sine function. Now this is just how they do it. Can you see? That's just exactly how did they do it. And before that, you have to specify the domain. Otherwise, the things can, if that is equal to 0, the things getting complicated. So if that is if this is constrained, you can just use this. So dx dy is cosine y. So therefore, the dy dx. So they just can you see? Just rewrite. They use this formula. Use this dx dy equal to cosine theta. Then you can see that dy dx equal to cosine y. And then they use the trigonometry, Pythagoras theorem, can you see? So you can rewrite cosine y in terms of the sine y. Okay. And then what do they do? They just follow this interest. So this just, you see, the cosine. They just, because they already obtained this result. What you need to know is that you just rewrite the cosine in term of the sine. Yeah, I think this is very interesting formula. Do you have any trouble to read through this demonstration?
No.
Oh, good. Okay. So why don't you use this method to redo that question we just encountered? Can we go to the whiteboard, or do you want to try a different thing?
This is a question that we did in class.
Yeah, you can either use the formula, or you can just using the this particular method.
Yeah. Could we try some complex questions of this? Because I'm not sure how to.
Well,
because the other one, it's just
go
a
on.
formula.
You can use different functions other than sine function, all right, to see if you can solve this puzzle. Can you try say cosine? Can you try cosine? We haven't found the derivative of the inverse cosine. Do you want to try how to solve the cosine?
Yeah.
Okay, let's go to whiteboard then. I cannot do anything. cannot share. Yeah. So we can use this method. That's I'm wondering, because it's not much point to just use the formula, right? So if you just use the formula, you can try if you want to take this chance to try. Or how can I write? So this is actually this is the first one. The second one is to find the derivative. So that's y equal to cosine inverse. All right. So trying to find the first derivative. So what can we do? Can we use that formula, that method we just learned? Perhaps first you need to rewrite this one as before you go. Can I show you? Because you can't see much. You see, can we just rewrite this? That's how we start. If I use this method, I would just rewrite this one as this one. Can you see this? So this is simply equal to x equal to cosine y. Do you agree?
Yeah.
Okay. Can you start? That's the first step. You will see what are you doing. Yeah, we know dx dy is hang on. How do you know?
Oh, would it just be that?
I don't think so. Do you if you follow this one, what would be the dx dy? So dy dx dy, that's right. That's dy dx. What's the dx dy?
Sine.
Negative sine.
Negative sine y.
Yes, that's right. Yes. So this is step one. All right. We can summarize this formula. Before you go to different function, we have to get familiar with this method first. Okay. Otherwise, you cannot simply guess. You have to follow this. So what can we do without that? Okay. Dy dx equal to negative sine. Yes, that's right. So what I'm looking for? So can we just say what? Can we just write down here? What we are looking for is dy dx, right? So we are looking for this one. How we now after this differentiation, we know that. So basically, this is step by step. We have achieved that dy dx, but not dy d. Do we got dy? Oh, we got it already. Oh, we got it already, right? Dy dx.
Yeah.
Okay, you have done that. So 3 steps. Now,
but it's not
it's not the x yet. So what is sine x? So that's something we have to do something about it. What do you go? Sine cosine? You can say so, but is any chance? Think about it. Do you remember we just we can rewrite that indifferently? It's 10?
Because
it's not 10. No, it's not 10.
1 over cos x. Is that not inverse cos?
Originally dy. No, how did you tell me, because I cannot see it. How I cannot see the argument. How did you rewrite y or? Oh, y? Oh, that's right. Oh, you substitute. Okay, I substitute that. Can I follow you? So this is y. Okay, this is y. So what can you do next? I don't think so. I think this is wrong. Okay, think about it.
I'm not sure.
Yeah, you forgot. You see, you cannot move. Can we just return to? You have to. You have invoked the Pythagoras theorem. See, you have used sine. Sine. If you just talk about the y, you sine square y plus cosine square y will equal to unity. Can you see how do we use? How can we use this formula to help you?
not sine.
Cosine y.
Oh wait, no, we're trying to find sine y, right?
It was sine y, yes, change sine y, we solve sine y. No, we need to find the sine y. Yes, you're right. You're very right. How can we find the sine y? A negative sine y here. Yeah.
And then
positive. Yes. Yes, that's right. So did you realize? So that is because I noticed that you have used this one. So that's the first step is very important. Can you see? Highlight the key to solve this puzzle is to use this relation, to use to rewrite a cosine y as x, so you can find this formula. So don't forget, if you don't use this formula, you can't solve this problem. Okay.
Yeah.
All right. So are you sure you know this form? We can change different function if you think you know this method. You can try different function, right? More challenging one. Why don't we just keep doing the tangent? These are very small, they are very basic trigonometric function. How about tangent function? So what in other words, can you just write down here? So in other words, what is oops, let's use draw. Let's consider y equal to tangent x, tangent x arc. So this is an inverse function. So what would be the first derivative? We can use the same method we just learned. Dx dy. How do you know that is a cosine square? Did you use any formula?
You can use the quotient rule to do it, but I know that because of methods.
Now you first you have rewrite this. Did you do that? I can't see. How did you get the result? You see, you have to communicate with your readers. Yeah. That's right. So that is dx. You can use the formula. Yes. That's quotient. Yeah. The quotient rule can let you. Yes. Okay. So this is step one. What else can we do? Okay. So what can we do next? So we have to rewrite this function in terms of tangent. What can we do? Sine, cosine square in terms of tangent. dx dy. Yes, we got the dy dx. We are looking for dy dx, right? So the dy dx was just a reciprocal of this function. You just rewrite that into the. Can we just you don't have? Can we just rewrite this as from here? Can we just invoke that formula as this method? That will give you dy dx, right? Into the reciprocal cosine square y. Now the question is how to rewrite a cosine in terms of tan in tangent. So what is tangent? So think about that. What is a tan? What is a tan y? Can we rewrite tan y? And normally we just use tan x, right? Tan y is still a trigonometry function, where y is the angle. By definition, what is a tan?
Sine over cos.
Yeah, you can try that way, yes. Okay. How can we get rid of that? Yeah, we still got a sign. The trick, right? How can we solve this one? This is challenging one because there's no guideline, see?
Yeah.
So we have to think how to rewrite this cosine square y in terms of tangent x. Not necessarily tangent x, but we just rewrite that x, okay? That represents x. So we have prepared these ratios, right? Do we have the ratio? We got cosine, unfortunately. So this is still how to use trigonometry, can you see? You have to think how to use this, not trigonometry, how to use this Pythagoras theorem, you see, Pythagoras theorem. How do we use this formula?
We did use it here.
Where? Oh, you rewrite that already? 1 minus sine x. Well, that is one way to do it. That is one way to do it. Any other way to do it? It's a cosine x. Can we divide it by 1? Is that possible?
Is that not just cos squared y?
No, my suggestion is why don't you try cosine square y divided by y? It's nothing changed, can you see? These two, there's nothing changed, all right? Do you agree? Now, think about it. What else do we know? You see, if you, I noticed that sometimes you always jump to the challenging question, but without doing the whole, to do the proper preparation, you can see. I have give you a clue, but can you follow me?
Yeah.
What is 1? Why did I use it? Why take this trouble to write this of apparently equivalent form? What is the motive? You see,
can you do?
Yes.
So that.
Yes, I give you a clue. You have to digest. Why did I do that? Well done. Yes. Okay, what can we do next? Can we just rewrite this in terms of the tangent? That is a trigonometry knowledge, right? algebra as well. We still have some space here. No, how this count? This is not right. I have to get, this is not right. Think about it. This is right, can you see? So far, so good. This is correct. This is what I expected. You see, you have taken advantage of this Pythagoras theorem here.
Yeah.
No, keep your mistake. Otherwise you can't. It doesn't matter. It's good to know when you made some mistake. It's good to know that. Okay, if this is right, can you try again? Can you try once more? Can you try once more? Can you jump from here? And 1 sine cosine square. Yes, you are walking in the maze. You see, in the maze. I'm standing on the tower, so I can see. Yeah, it's the maze. Now, I noticed that you're all right, but this time you in many cases you are all right, but this time you don't know what the consequence of this crossing. How did you cross this? So can you see if one equal if something x equal to a plus b, can we simply cross a? Think about it.
That's what I did here.
No, you can't. This is wrong. I'm not going to tell you.
Can't you have 1 plus?
No, let's just need to be crowded. This is something very interesting. So, are you sure you get this?
Can you only do that in multiplication?
You see, I just consider this example. If this is a, this is a plus b, right? Do you think that equal to b? You can cross. Can you see that? Is that what I have done here?
Is it equal to 1 over 1 plus b? And can't you cancel them out?
You can try. This is the issue. You encountered this time. See, obviously, I just give you the conclusion. This is certainly not okay. This is wrong. Think about the correct one. Think about you cannot cross this a in this simple way. No, wrong. Did you guess?
Yes.
You don't guess. You see, if you have fractions, so some students, yes, this fraction is actually is basic. You can see, I show you some the correct way. So what are you trying to do? You don't cross. You're trying to divide this everything by a. Do you agree? And this is a plus b divided by a. That is allowed. Can you see? Nothing changed. You divide the numerator by a. That's okay. Okay. So in this way, you got a. It's got a unit there, but you still have to finish this fraction. Sorry, it is a plus b. You have to finish this fraction. You see. Now, can you tell me how to simplify this fraction?
Equals 1 plus b over a.
You can write the result. I can see. Yes. Okay, return to the question. So what is the question? So we got a cosine. Can we just continue this exercise? So therefore, so this is just example. And we have cosine square y. Then we'll first rewrite this as cosine square y divided by unit. Okay. And you can write, okay? So you can write from your side. What did you do? You rewrite unit as a sum of the sine square plus cosine y square. Yes, what do you do next? Yes. Can you see that?
Yeah.
So that is doesn't matter. I sometimes I'm just, that's why I use a whiteboard to observe. So in this case, you have to be careful about this algebra, okay?
Yeah.
Algebra, so is correct. Okay, you can choose a challenging question now. Now I think you know how to. Can we choose more challenge? Can you pick up from your textbook?
Yeah.
That is.
I'll take a screenshot and then use it so that we can both work on it together.
Okay, right. Your screenshot, you can. You can just write. Can you just copy the function? That's all. You don't. This is not a word problem. You just copy the function. We can do this. You use a pen to copy your. You don't have your screenshot. You just write. You see. You just write the question or the function on this on the blackboard. See, it's easier.
I'll just put this because it's a question one, but the other ones I think we already kind of did.
Oh well, we can only do one question
it's a lot of,
at a time. You can just write one question.
Yeah.
And then we do next if we have time. Yes. Velocity, VT.
And
okay,
then it says,
yeah, that is a reverse function. Yes, that's right.
How many minutes pass before the rate at which the volume is increasing reaches?
Oh, this is a word problem, right?
Yeah.
So
we have to find out.
What is, you need to find the first derivative, do you?
We have to find out t.
At this particular value v, right? What is first derivative, or you need to find the v, right?
Yeah.
No,
and we already have v. V is 1.197. We have to find t.
We need to find at what, also when velocity equal to that, what is the t? All right.
Yeah.
Oh, that you don't do. Do you have to use a calculus? You don't have to use calculus. This is a trigonometry problem, right?
Yeah.
Okay.
I don't think you can use your calculator for it.
You need to. Let me see. What's the problem? Can we just rewrite this as we did? Can we just rewrite this formula first? Can we just rewrite this as 27t equal to 10 velocity? Is that formula, right?
Yeah.
So they give you velocity, and in order to find the t, is that a question? Okay, we just substitute that. So t is solved. Can you see?
Yeah.
Can we solve that way, or do they have other requirement? That is how to solve that. Is that how to solve?
That's all the question said, and it's one of the harder questions.
Can we share your textbook? I will read that because it's so simple. It's not hard at all. I mean, no one can memorize, or no one can, solve the trigonometry function without this calculator. For some special angle, we can do that. Maybe this value is some, can be rewritten as a sum or difference of two familiar value. I don't think so. Now, I think the best we just go to your next top there. You can go to, I can see the question. What is the original question? The last one, the last question.
This is the original question.
Which one? Which number? What is number? 19?
14.
14. Okay. Volume. Oh, I can't see. Can you enlarge that?
Yeah.
Okay. I can only see 16. Oh, I can see it now. Yeah. Could you read the question? Well, it's not stable.
Yeah, this app is kind of a bad app.
Ah, yeah. Can
Okay,
you read
the
the question?
volume in centimeters cubed of water in a tank after T hours is modeled by volume T equals inverse tan 2.7 T.
Yeah.
How many minutes to the nearest minute pass before the rate at which the volume is increasing reaches 1.17 centimeters an hour?
Yes. What is
Does the rate at which mean we have to do the derivative for it?
How many minutes? The nearest minute pass. Oh, that is a formula for the volume change, right? Before the rate at which the volume increasing reaches that per hour. So they are talking about, yeah. So it's not, the condition is not for the volume. The condition is for the rate.
Mm-hmm.
So this condition is given 1.197 is the first derivative of the VT, isn't it?
Yeah.
Got it? Yes. So can we just return? I know the question now. Can we go to the whiteboard? So the you understand, your interpretation is not correct. This time, the if you go to whiteboard, so these conditions, so this is not right. So actually, what does it say? So that is the given condition is that the first derivative its first derivative equal to this number, okay? 197, and what is the t? That is the question. Can you see? Not as a function itself, but the first derivative. So yeah, you are right. You have first found the first derivative. Can you try how to find the first derivative first? What is the dv dt? You have to work out this first. So this is step one. So this is step one. Can you see? Step one. Yeah, we got formula. We got the formula for tangent. Just we got formula for tangent. Do you remember the formula here? Can we just highlight the formula for you? So the tan inverse first derivative is equal to 1 over 1 plus x squared. Yes, that is the function. Okay, can you take this? Can you apply this formula to solve this problem? You don't have to use that method all the time. Okay, do you want to try? So this is a basic formula. Can you use this space to do this first derivative?
Is this down here?
Yeah, down here. This corner. Not quite. You have used a chain rule. Can you see this is not x? This is 27x. Is that 2.7 or 20?
Yeah, 2.7.
Yeah, 2.7. So you have to use a chain rule here. You want to show you how to use a chain rule?
Oh, so times 2.7.
Yes, that's right.
So
yes. So the condition is 1.197 is given, right? What is the t? Can we solve the t? Can we solve the found formula for t first?
So first we have to find out what time this is happening at.
No. What do we have to find? Well, you have to, yeah, you have to solve. You have found the formula for t in term of the first derivative first. This is for, you can do it because you can from here you can do that. What is the formula for t? This is so far so good, but what is the formula for time? No, double check. Can you slow down? You miss out something. If I just highlight, so this is not right. You miss out something. From here to here, are you sure this is the right result?
Do you have to substitute this in?
No, this is no. This is the wrong one. Don't forget about that part. That is incorrect. That is a misunderstanding. Yeah. Now, can you read this question? Can you read this equation carefully? Can we find the mistake? So this from here to here, from this result to here is not right. So what is wrong? Can you see what is wrong?
Can you get dv?
Yes, you have taken into dv dt into account. It's not. Yes. Why did you separate this derivative?
By cross multiply.
Oh yes, you multiply. Yeah. Why don't we divide the whole things? Why don't we divide the dy dt as a whole? I know what your motive. Why don't we divide this as a whole? You know what I mean? Why don't we divide this as a whole?
Will that just be v over t?
No, we just divide this as a whole, can you see? Let's rewrite that. Think about it. You see, this is something. Can we call this A? Can we call this A, right? If this is A, then we got one. Oh, hang on. You made that. Probably that's your. This is not right. This is not right. Think about it. Can you check? So how this is 1 plus? Can you see originally? This is 1 plus 2.7. How can you get this one? So this is wrong, can you see?
Isn't that the same thing?
No. So one is, can we just write down here? So you have, can we just do it one by one? Can we just check that dv dt as it is still there? The only thing you can do is that you just multiply the whole bracket, which is a 2.7 square, can you see? Equal to 2.7, wait, 2.7, yeah, 2.7, yes. Got it? And then we just divided the whole in order to solve the t. It's just algebra, can you see? Can we call this A? If this is A, then we can get 1 plus 2.7 t squared equal to 2.7 divided by A. Can you see? Can you continue? To solve for t. Yeah, we are looking for formula for t. Yeah, you take 1 on both sides. Yes. How can we find the t? Okay.
T equals that.
Yes, and that's right. It's right. Divided by 7. Yes. Yep. You can substitute condition with your calculator now. Can you see? The condition is not for function, but for the first derivative. You can substitute this function now. Can you see?
Yeah. But, oh, okay.
Do you understand? Can you follow me?
Yeah. Yeah.
Yep. So that's it. That's a solution, isn't it?
Yeah.
Can we pick up another one? Can we look at your, can you share your, before we go, can we share your textbook to pick up a question? We read this question first. If the question is just a simple function, you can copy it on the whiteboard. Can we, I stop here. Can we share your textbook again to pick up one question? Another question. Which one?
18.
Which one? 16?
18.
18. Okay. You can read now. That will help you to understand what is the question.
Determine the coordinates in exact form of the points on the function y equals arcsine 7 minus 3x, at which the gradient of the normal is equal to 1 over 24.
Oh, gradient of normal. So the normal is perpendicular to the gradient, right?
Yeah.
The gradient of normal. Well, how to interpret that? Gradients of the normal. Ah, yes, that's right. So that is I know this question now. Can we just this is a 4 sine. You can write the detail. I can't remember. So what is function? So I can. This is a sine, right? It's arc sine. Oh, you can copy the question. We can solve the problem. Yes. So the interpretation is a gradient of normal. So that is a gradient of the normal, not the tangent. Okay.
Yeah.
So if I give you the help, do you need help? You want to try without any help? You can try.
Could I get help?
How to reinterpret that wording? That is a keyword. That is a gradients. Gradient of normal. Yeah. So if you understand this, then you have no problem. So this is condition is given. Gradient of normal. So for any function, we know that this is for any function, dy dx. Yeah, you can draw the diagram. Yeah. What does that mean? This is a gradient of tangent, isn't it? Gradient of tangent. Right? So that's it. So that is different. So what is the relation between these two tangents? They are perpendicular to each other. That's right. So if that can we say that is if that is a curve? Can you see? If that is a curve, so this would be a tangent, right? It would be tangent, and so this would be the tangent. How do you know the number? How did you the number? Did they give the number?
They said the gradient of the normal, which is this.
This is normal. Yeah, this is normal.
Is 1 over 24.
Oh, that is the equation. So that is can you rewrite? So this is this normal can be written as y equal to 1 over 24 multiply x plus the constant. Okay. So this is normal, and this is tangent. All right. So can you write the tangent function based on the normal?
Isn't it? Are the gradients equal to 0?
No, it's a reciprocal negative. Did you forget this part? We can put the d here. Can you see? So if the two straight lines are perpendicular, their gradients are the negative reciprocal.
Yeah.
So this is indirect. This is for condition by implication or by connection.
Mhm.
So they give you these very tricky conditions. So they give you, they didn't give you the gradients instead. They give you the gradient of the normal.
Mhm.
But if you know this condition, can you see it? Can you see the change? What I changed?
Yeah.
So so then you should be able to interpret this. So what does this number mean? What is this now? What is negative 24 means in this case, in this context, in this question?
It's the gradient of the tangent.
Yes, it's the first derivative at that particular point, right?
Mhm.
So that is the condition, isn't it? We need to find. So if you just want to can we just this is a hypothetical graph. It's just to help us to understand this one. So therefore, if this is y, this is x, all right? This is origin. Now, based on this question, can you find this x? So this is x. Can you see?
Mhm.
Can you find this particular x based on this condition?
If you use the derivative of this to find out
Yes.
when not y equals 24,
yes.
then you can find x.
Okay, try it. Yeah, that is how. That is how to solve the problem. Did your teacher demonstrate this method during the class? They just discuss example in a textbook, right?
Yeah.
I see. Stop. Wrong. Why? Why is it wrong? The only formula, can I show you? Don't take easy. So the only formula you will know that the tan negative inverse first derivative equal to 1 over 1 plus x squared. We just derived today, right?
Mhm.
Because, but this coefficient is 1, can you see? Then this coefficient is not 1.
Yeah.
See? Hang on. This is not, sorry. I'm talking about tangent. This should be cosine tangent. This could be tangent. Anyway, so this can we just rewrite this one? The function we derive in the first question is a sine inverse. First derivative equal to square root, positive, right?
Mm-hmm.
Minus x squared, right?
Yeah.
Now, be careful. X is, so can you see this is sine, but this is a composite function. So this is a composite function.
Oh, so it's times the chain rule. So
you have used a chain rule.
So it's this times.
No, can we just time what?
Times -3.
Yes, that's right. But to help you understand, can we just rewrite this as this? Can you see? Can we introduce a new variable? U equal to 7 minus 3x. In this way, you will not make a mistake, right? So that will give you du dx equal to negative 3.
Mm-hmm.
According to the chain rule, dy dx were equal to dy du, right?
Yeah.
And multiply du dx. That's why you would never forget this -3, right? So therefore, you can try it again. No, 1 over.
Yeah, I just write the square root.
You get square root. Okay. Oh, fraction, be careful. This is 4.
Mm-hmm.
Let's multiply.
Yeah.
Okay, can we solve this? Can we solve this x?
Mm-hmm.
Yeah, you have built the equation first. Yes, that's right. Okay.
That's X.
Yeah, that's it. That's it.
Mhm.
So that is very useful method we have encountered today. Any other questions?
No.
No.
Mhm.
Are you going to have the physics tutoring on Friday?
Yeah.
Oh, in that case, can we this particular week can we start at 5:30 as well?
Mhm.
I got a
Sure.
student. Yeah, he will do some lesson on Friday.
Mhm.
So I see you at 5:30 on Friday this week.
Yeah.
Just this week. Then we can back to normal. Okay.
Okay.
Okay. I will send that to you.
Mhm.
Okay.
See you on Friday.
See you
Thank you.
Friday. Goodbye.
Bye.
Goodbye. Stop.